Hey everybody, so in this video I'm going to be talking about what the row echelon form is and how to rewrite an augmented matrix like this in this form. So let's go over the rules and how it works. So the first rule is that if you have any zero vector or like a row that's full of zeros, um, it must be placed all the way at the bottom. Okay, so if let's say we had a zero vector right here in the middle, then currently that matrix is not in row echelon form. Therefore, that row full of zeros, in other words, a zero vector, should be placed all the way at the bottom. And you're allowed to do this interchanging manipulation of moving rows from top to bottom. It really, you, yeah, I mean, you keep the matrix the way it is in the same form. Okay, and then so the next rule would be that each leading entry in a row is in a column to the right of the leading entry of the row above. Right. So let's talk about that. So let's say you have a matrix here. You have 1, 4, 6. You have 0, -3, and 2. So a leading entry is the first non-zero number in a row. Okay, so these are rows, these are columns. So in a row, the first non-zero number is the leading entry. So in this case, we have a leading entry here, and our leading entry in this row is this number. So, and what that rule is saying is that each leading entry, okay, should be in a column that's to the right of the leading entry in the row above. So let's take a look at this leading entry. Is it in a column that's to the right of the leading entry in the row above? Okay, so the leading entry in this row is this one. The leading entry in this row is this. And it happens to be that it's in a column that's to the right of the leading entry in the row above. So that is an example of satisfying that second rule that I showed. Okay, and then the last rule is that all leading entries must have straight zeros beneath them. So with the exception of being the last row. The last row, I mean, there's no more entries, so it's all right. So in this case, this leading entry doesn't have any zeros because it's the last one. All right, so let's just talk about the first one. The first one, all right, we said the leading entry is the number 1, and it has 0 beneath it, so that's good. This leading entry, okay, doesn't have, let me just draw a better example. So let's say we had 5, 4, 3, 6, 7, -1, 0, 0, and a 0 like that, and let's see. Okay, so this matrix right here, that's a 3. Where's our leading entries? All right, the first non-zero, first non-zero, the first non-zero. So this is an example of it not satisfying the row echelon form rules because this leading entry doesn't have straight zeros beneath it. Okay, however, this leading entry, I mean, no, that's not a leading entry. This leading entry has a 0 beneath. Let's say this number right here was a 0. Okay, that satisfies. We have our leading entry right here, satisfies, it has zeros beneath it. And this leading entry has nothing but zeros beneath it. Okay, this is a 0, not an A. So that's what that third rule means. So let's just jump right into a problem where we're going to rewrite this non-REF matrix into REF. Okay, so let's just begin. So we're going to follow an algorithm that begins with the row on top, the uppermost row, and we're going to work our way downwards. What we're going to do is, all right, starting with the first leading entry in the first row, and we're going to try to manipulate it in a way that makes all these entries below the leading entry zeros. Okay, and then after we do that for the first leading entry, move on to the second row and try to manipulate it in a way to have zeros under the second leading entry. So we want straight zeros under this one right here. And what we're gonna do is that we're allowed to multiply each row by a number and then add it to the other rows. So what we're gonna do is, all right, we're gonna select 2 rows. One of them, we're gonna multiply it by some number. We add the 2, and then what we get from that, we could replace it in either one of those 2 rows that we selected. So I want a 0 in this position. So what I'm gonna do is multiply. Okay, this is row 1, this is row 2, this is row 3. I'm gonna add row 1 with negative row 2. Okay, so that's plus negative. Okay, plus negative row 2. And then this arrow means where I'm going to place it. I'm going to place it at row 2. So what we have is 1, 1, 1, 4. Okay, and we're going to add it to negative this row. So negative 1, negative 2, positive 1, and negative 1. Okay, and I'm going to add those two. And what I get is 0, negative 1, 2, and 3. And this what I got from the addition of those two, I could place it in either row 1 or row 2, but the most strategic choice would be placing it in row 2. So I'm going to go ahead and rewrite this matrix with the replacement. So I have 1, 1, 1, and 4. And then I have 0, negative 1, 2, and 3. And then the third row, this stays the same because I didn't do anything to it. 1 and 3. Okay, so now, oops. Okay, so now I can what I want to do is have a 0 in this entry. So the way to do that is multiply row 1 by negative 2 and add it to row 3, and then place what I get in row 3. So, okay, I'm going to do negative 2 R1, and I'm going to add it to R3, and I'm going to place it at R3. So, okay, so negative 2 R1 would be negative 2, negative 2, negative 2, and negative 8. And then R3, I have 2, negative 1, and 3. Oops. And now I'm going to add these two. And I get 0, negative 3, and negative 5. And this, I'm going to place it, as I said right here, I'm going to place it in where R3 is. Okay, and rewrite the entire thing. Okay. Alright, so we're done with rewriting this matrix having all zeros under the first leading entry. Alright, second leading entry right here, I'm going to manipulate it in a way that I'll have a 0 right here. And what I'm going to do is add these two rows, okay, so R2 and R3, but with R2 being multiplied by negative 3, so I'd have positive 3, negative 3 here, and then they cancel. And I'm going to end up placing it at R3. So, okay, what I'm going to do is, as I said, I'm going to have negative 3 R2, and I'm going to add it to R3, and I'm going to place it in R3. So that, it gives us, okay, so I have 0, 3, negative 6, and negative 9, and I'm going to add it to 0, negative 3, and negative 5. All right, I'm going to add these two, and what I get is 0, 0, negative 9, negative 14. Okay, and this, I'm going to place it, as I said right here, I'm going to place it where R3 is. Okay, and what that gives us is 1, 1, 1, 4, 0, negative 1, 2, and 3, 0, 0, negative 9, and negative 14. Okay, and let's check if it satisfies the 3 rules. Do we have any 0 vectors? Nope, we don't. So, okay, each leading entry in a row is in a column to the right of the leading entry in the row above. Okay, so let's circle our leading entries. So 0, 0. Oops, I mean this, this, and this. All right. Each leading. Okay, so let's start with this one. Is it in a row? I mean, in a column that's to the right of the leading entry in the row above? Yes, it's to the right. This one is to the right. Okay, that satisfies the second rule, and then for the third rule, all leading entries must have straight zeros beneath them. Okay, so we circle the leading entries. Do they have nothing but zeros beneath them? Yes, yes, and then the exception for the last one. And that's it. So this is the rewritten augmented matrix in row echelon form.